At the end of 2020, you may have heard the news about the collapse of the Arecibo Telescope. This giant radio telescope was built in Puerto Rico in 1963, and chances are you've seen pictures of it, especially if you've watched movies like Contact or GoldenEye. Arecibo has been an instrumental part of understanding our universe and in the search for extraterrestrial life. It also holds a very special place in the hearts of scientists, like Abel Mendez. He's a professor of physics and astronomy and the director of the Planetary Habitability Lab at the University of Puerto Rico. And he explained to me just how valuable Arecibo has been over the decades.
Well, the Arecibo Observatory is also used to study planets, stars, galaxies, and the rest of the universe. And Arecibo, among many other discoveries, detected the first confirmed extrasolar planets in 1992. But the most important job of the Arecibo Observatory is part of the NASA Planetary Defense Program. So asteroids are detected by many telescopes around the world. Once one of these detection is the orbit calculated, and we know that is approaching Earth or could be dangerous in the far future, then that information is given by NASA to the Arecibo Observatory. So that radar capability allows to send a strong signal from the observatory to the asteroid and bounce back. And from that bounce back, we get a lot of information. We get the size of the asteroid, its position relative to Earth, and its velocity and direction. And especially the size is something that optical telescopes cannot determine as good as radar telescopes. So that's why important just to tell apart if this is something big enough for that we should be concerned or not. But what is the next best radar after Arecibo? So Arecibo, I told you there is 305 meters diameter. So the next best one is 70 meters.
Oh, wow.
So that's a huge difference.
Yeah. And, we're talking about all the things that Arecibo did do because in December 2020, the dish collapsed. Mm-hmm. And this is a big blow for scientists like yourself.
Oh, yes. We were, last time I used the observatory was in August 6th. 4 days after that, in August 10th, there was the first cable failure. And the Arecibo Observatory had to stop doing observations since early August. At that moment, that was a failure of an auxiliary cable. It's a smaller one. And the rest of the cable were supposed to withstand all the additional weight. So we were not that concerned that moment. So we thought, well, maybe that will be replaced in 2 or 3 months and we can continue doing observations like usual. But then on November 6th, a second cable broke. And now that it was one of the main cables. So at that moment, we knew that that was a critical condition. The remaining cable were withstanding about the stress that they were designed for. And we were trying to push the National Science Foundation to try to stabilize the observatory after the second cable broke. We knew at that moment that at any moment the observatory could collapse. And then it just broke up in December 1st, in the morning of December 1st.
Right. And the way I understand the structure of the telescope is the dish is down below. It's sort of nestled into a natural sinkhole in Puerto Rico. And then above that, suspended from cables are these the instruments or can you explain a little bit about the design?
Yes. The observatory was constructed in a natural sinkhole between the mountains in the town of Arecibo, which is a northern town, but it's very close to the center of the island. And that there, what everybody recognizes is the dish which looks from pictures like a solid structure, but it's more like a mesh. So at the center, suspended, is a huge structure which weighs about 900 tons. That structure or the platform is where all the instruments, the receiver, and because it's a radar, the transmitters are located. So the most important instruments were at the center there. All the remaining thing was just metal and, and suspension, but those were the main instrument were located, and that platform was the ones that collapsed, destroying all the main instruments.
Oh, wow. So the instruments and the dish were both destroyed.
Yes, the dish below sustained a significant damage, but even so, people are considering that it could be repaired. After 57 years of operation of the observatory, there's a large scientific community that has been using for decades this observatory. So we got together and started having meetings and deciding what could be the next Arecibo version 2.
So are they really considering rebuilding it?
Oh, yes. The most important thing is that if we want to ask for a new observatory, most important thing is science. So we have to do the same science, especially the radar, which was unique in the world,
Mm-hmm.
but also something new. And that's good news for the scientists. So you won't have only a similar instrument, but also a better instrument, which will allow for you probably for new discoveries. So that's why we're getting together and just thinking about ideas of things we can do with a new telescope. And once we have that, then engineers can figure out how to construct something that will be able to do that science.
Okay.
And then we will have an idea, a more formal idea, how much it will cost to do that. Now we will have an idea what we will be asking for to try to get funding for that. Then we will start the process of construction. So this will take a lot of time. Could be 3 years, could be five, could be more likely even 10 years. And the advantage is that you want your telescope to be in a used territory. You want your telescope to be close to the equator because you will have a wider field of view as Earth rotates. And also, many of the planetary objects, including those asteroids that will be tracked, pass and are more observable close to the equator. So that same criteria still holds today, and then Arecibo is still the best place to construct such a telescope. And another advantage right now, not available at that time, is that there's the infrastructure already, buildings, facilities, scientists, people interested in using this observatory. So that would be the third reason for the observatory to be close in Puerto Rico.
It must be kind of exciting to be involved or part of the planning of a potentially new Arecibo, something that does a lot of the same things, but now you get to design it in a way that takes advantage of new technologies and new engineering capabilities, and you kind of get to build your perfect telescope in a way.
That's true. That's true. That's we knew that that's a big opportunity for any scientist to get involved in that in construction or the whole construction and of a new telescope. It could be larger. It could be composed of many dish in that region and even in the regions nearby. It could be something like the instead of having the platform at the center, which weighs a lot, now it could be just at the bottom, which is something good because of earthquakes and hurricanes. Could be at the bottom, and then at the top you will have just a reflector. It's amazing what you can do today compared to the original Arecibo. So it could be something much, much bigger and much more interesting.
I want to back up a little bit and talk a little more about what Arecibo has done. What role has the Arecibo played in our understanding of the universe? What discoveries have come from this observatory?
Well, in 1974, the Arecibo Observatory was upgraded with a new radar capability, and that opened a lot of possibilities at that time to determine the rotation period of Mercury, to map the surface of Venus. Then Arecibo was also, in that year, discovered binary pulsars. So one pulsar star orbiting another. And so, because there were strong gravity fields around these two pulsars orbiting each other, it served to re-verify the general theory of relativity and also provide the first indirect evidence of gravitational waves. And that observations in the 70s were awarded in the early 90s with a Nobel Prize.
Wow.
And continuing to the 90s, then the first exoplanets were detected. So while observing one of these pulsar stars, a team of scientists discovered that they were orbiting by up to 3 planets. And this was in 1992. And at that moment, and when they presented that discovery to the scientific community, everybody was in disbelief because, wow, for real, we are able to detect planets around other stars. So it was a big discovery, and the rest is history.
Wow. I see here why scientists are, they see Arecibo as so valuable. It's played a huge role.
Yes, and that's not counting that Arecibo typically observe about 100 asteroids a year. Some because there might be some risk, eventual risk for impacting Earth, but so far nothing critical.
The dinosaurs could have used Arecibo.
Yes, so we are back in this at the same advantage that the dinosaur.
Okay. That makes me nervous.
Yes, it is. Yes. Well, we have still radars, smaller ones, radars, and it means that we will recognize these potentially. We will have less time for preparation. But it's not something like days. It's not like in the movies that you detect an asteroid and in a few days it will. If it's big enough to cause large damage, I mean, for a city or the whole planet, it means that it's big. If it's that big, it will be detected long ago by other instruments.
Yeah. So one of the things that people might know Arecibo for, especially people listening to this podcast, which is about the search for extraterrestrial life, is the Arecibo message. Can you talk about the message a little bit and what its purpose was?
Yes, the Arecibo message was a signal that was sent in 1974 to a group of stars very far away, about 26,000 light years away. And that message was constructed by Frank Drake, a very famous astronomer, also associated with the Drake equation. And also Carl Sagan helped him also, and others helped him in the formalization of that message. So the message was sent in 1974 from Arecibo during a ceremony celebrating the upgrade with a new radar of the telescope. So as a proof of the new radar capability, they decided just to send that message. And it was during the day, so they picked stars that were observable at that time during the ceremony. And there was a group of stars that they decided at that time. We have to remember that there were not exoplanets known at that time, so there was no a place more interesting than others just to send a signal. So that signal is still traveling through space. As I said, it will reach in about 20, say 28,000 years its destination. So if we get a response, it will take that same time back. So it was not a message intended for a reply. It was more like a demonstration that of the new radar capability of the observatory. And the message is really famous, and it contains information about our numbers, chemistry of life, Earth population, the planets, and that we are in the third planet of the solar system. And even it included a small representation of the Arecibo Observatory. Arecibo is known and for that message, but also trying to use the observatory for searching for signals from other civilizations. And there have been a few projects. But the most complete study was in 1998 until 2004. Jill Tarter, which she's the scientist which inspired the character and the movie Contact. Well, Jill Tarter uses the observatory to try to detect signals from nearby stars. They map with Arecibo and other telescopes around 800 stars. And that was so 2004 was the last time that Arecibo was used directly to point at specific targets of interest, looking for any signal from a extraterrestrial civilization.
What happened in 2004?
Well, the project was funded by private funding, so that funding stopped. We have to remember that in 1993, Congress decided to eliminate any support and funding, government funding, for any project related to society, thinking that it was a waste of money and a waste of time. But the interesting news here is that in 2019, last year, Congress decided to change that back. So it's not called now SETI. It has a broader name. It's called techno signature. Any signature or sign of technology. And in July 2020, through the pandemic, there was also a request by the NASA exoplanet program. And they also requested any project from 10 signatures. And there was one that was funded. And that one in particular was the traditional SETI, just listening with a radio telescope, this time the Green Band telescope. And it was approved. It was approved.
That's amazing.
Yes, yes. And I am, even that I'm working in the field of astrobiology, and that so people say, well, you're in the field of astrobiology, so you think that they are aliens. Well, it's very hard when you're doing astrobiology. You start to feel like, wow, this is difficult. It's not impossible, and probably the planets are maybe very, very far away.
Yeah,
very, very far, because statistically, this is a large universe, and the planets to have all those conditions could be very rare, and they will end up very far away from each other, probably out of touch in terms of radio signal or something. It's not like we're doing this project expecting to find alien civilizations and then, oh, okay, we didn't find, well, failure, we fail. It's not like that. Imagine that we detect with the James Webb Telescope, and everybody's hopeful that it will be able to sample the atmosphere of this planet, and we detect oxygen and methane. So very hard to have both oxygen and methane atmospheres. That might be a strong indicator of a life process. What will be the next question by scientists and everybody else? Is there intelligence life there? And we will have to say, well, we don't know because we haven't looked at it.
Mm-hmm.
We will say no because we look at it. So I support this type of projects.
You work with something called the Planetary Habitability Lab. And this is basically looking to see if there are planets out there that are hospitable for life.
Yes, and in our laboratory, we study theoretical models that predict what will planet needs. So it's not only looking at extraterrestrial life; it's also looking at our Earth evolution of life. What were the moments that were more habitable compared to others? So that's our base of comparison.
Mm-hmm.
So we study Earth. We study our solar system, habitable place everywhere from Mars to oceans in the moons of Jupiter or Saturn, and then planets beyond Earth.
Okay.
So our interest is not necessary to find life, but to find places that are good for life. They might not have life, or they have, but that's equally important. Imagine, for example, that we find habitable place without life. That is a profound discovery. Our premise right now is that okay, anything that is habitable should have life or will have life, like it happens on Earth. But we don't need to go that far to exoplanets to test that this hypothesis. Is, for example, we sample eventually water from a deep aquifer on Mars, and we analyze there's water, there's nutrients there are any ingredients that if we put any terrestrial life here, it will grow up. But we don't detect any life at all there. The solution to this problem is all habitable place means life could be as close of Mars, and we can test this on Mars. And that will be profound because, wow, even that the places are habitable don't necessarily end up with life. So something happened different here on Earth that we were lucky for that. And that's equally important.
When you think about finding a planet that even as close as Mars that might be habitable for life but doesn't have life on it, do you then think about introducing life to a place like that, or is that sort of a taboo?
Well, there's a big problem here, an ethical problem here. Even if we don't find life, which is hard, it will be hard to prove. Anyway, you're trying to prove a negative. So, but let's say, okay, we can be sure there's no life on Mars at all. Well, fine. The planet is for us to do whatever we can do, and we can introduce terrestrial life if we wish, and that will have some consequence for the planet. But probably will be more free to introduce, and it will be inevitable because if you introduce human life there. So anyway, but is there's life there? Yes, now you have an issue. Yeah, you are trying to share the space with that life. You need time to study that life. You don't want to destroy it, contaminate it, and just to be 100% sure, you don't want it to contaminate you back.
Right.
Which is less likely, but you have to be very careful anyway. So if we find life, we will be more careful than before, and we haven't been that careful, so especially for the first planetary missions. And that will be something that we will need to protect because there are implications of that life. Is that life related to us somehow? Do we share a common ancestor? So many questions that the answer is right on Mars. So I love Mars because it's right there, and there are many answers to many things right there. And then we'll move up from that.
Yeah. So while Arecibo is out of commission, and here's hoping that they will rebuild it and into something even better for you to be able to use. What are you going to do in the meantime? How are you going to do the kind of work that you
Well,
do, and what's going to fill the gap of Arecibo while we wait?
at least in our laboratory, we do a lot of theoretical work with data from different instruments. And our Arecibo project was one of the big projects of our laboratory, and that's the one that will be affected.
Mhm.
Anyway, we will try to continue doing observations using probably other radio telescope like the Green Bank, but that will be a downgrade in our sensitivity by a lot. So best next choice is the one in China, but that will be a small time. There will be a lot of competition. I don't think that they're designed the telescope to be used remotely yet. You have to be there, or one of the Chinese scientists supporting your work will be doing the observations for you.
And will the work that other scientists were doing with Arecibo, will that also be shifted to Green Bank and the Chinese telescope, assuming we can get access?
Yes, that's what is supposed to happening. That all these 100, more than 100 observers, but telescope time is limited because there's strong competition and we will be observing less things. So that's why every telescope counts. Or even if there is a extraterrestrial civilization sending signals, it's very faint, which should be very faint anyway, then it will be detected in China. But if Arecibo were there, it will have the same capability, and you will have to wait 12 hours as Earth rotate just for Arecibo to pick up the signal and confirm the signal, and also getting that data, and we will have confirmation. Right now, we don't have that confirmation. So if something like this happened with China, we will have to trust them because there was nobody else to tell us that true or not.
I have one last question, which is when in around November 6th, 2020, when the second cable snapped, and they were talking about just decommissioning Arecibo before the collapse. You mentioned on Twitter that you were about 10 or 11 when you walked below the dish for the first time. Can you talk to me a little bit about how Arecibo has factored into your own life and what it's meant for you?
Yes, my first visit to observatory, I was 12 years old. I was already interested in astronomy. So I decided that I wanted to see the observatory. And what I did is that during school time, I called via payphone the observatory. At the time, we didn't have a phone line because we were living in the rural Puerto Rico. We didn't have a phone at that time. It was 1981, but there was one at our school. So I paid that 10 cents. I made the call, and one of the staff there. So you had to make a reservation. So I talked to him. I told him that I was a student. I want to see observatory, and he said yes, okay. And he and made an appointment to one particular day in the week. So I skipped school for that. And I just went back to home, and I told mom, dad, I made a reservation for going to the observatory this day, and they say yes. So we are going to the observatory for the first time. So it took 2 hours that time, and that staff member was very nice with me and my family. And I had even something that I know right now is giving only to VIPs. I went under the dish. That day in particular, there was a maintenance day. You could go down the dish, but that was only given for a few VIPs. So this staff decided to give me that. We went with a jeep below the dish, and you can see through the dish, to the mesh of the dish, the platform up there. So I had the time of my life. I went to the control room that I will be using a few decades later. And went to the library there with a musky odor of books, which I still have. and that was an amazing time for me. I don't think that was that gave me the inspiration, because as I said, I wanted to do astronomy, but that was like a reinforcement that Arecibo, it was like a support community that I had. Probably if it were not for Arecibo, my interest on astronomy here in Puerto Rico will be very limited. Maybe I shifted careers or something. But Arecibo, it provided me like an empowerment. I felt like, okay, we have Arecibo. We have something powerful, unique in the world right at home here. So that gave me an empowerment, a confidence that I could do astronomy, that has been something that, especially through the later years, had a huge impact in my career. And that's why we're talking about this.
That was Abel Mendez. He's a professor of physics and astronomy and the director of the Planetary Habitability Lab at the University of Puerto Rico. You can find him on Twitter at Prof. Abel Mendez. You can follow us, too, at Wild Thing Pod. And if you want to be kept in the loop about what's happening with Wild Thing, you can sign up for our mailing list. Go to wildthingpodcast.com. This podcast is a production of Foxtopus Inc. Our executive producer is Scott Carney. Editing is by Alicia Lipinski Lincoln. And the score and sound mixing come from Louis Weeks. I'm your host and creator, Laura Krantz.